Hi and good morning to our lecturer and fellow friend. So today our group will present project presentation, and before that I will introduce my team members, which is Muhammad RaFiq SyiMir, NURUL IZZATI, Noor BATRISYIA and AMIRAH. So our title for this project is using Newton divided different method and natural cubic spline method in engineering geology. And this title is from chapter 4, which is interpolation. In this project presentation, the content is introduction, literature, methodology, calculation, discussion, and conclusion. Next, I will continue my part, which is background of study. As we know, numerical methods are used in civil engineering works. We take geology engineering as our study to identify the method and solve the tabular data given. In addition, we focus on the interpolation chapter. This chapter is about two types of interpolation, which is Lagrange interpolation and Newton divided different method. All these methods are included in the polynomial interpolation method. And another category of interpolation is piecewise polynomial interpolation, which is include natural cubic spline and clamp cubic spline. The next, we focus to our problem statement of our group, which is geology is a scientist who study the earth of history, resource, and geological phenomena. They analyze the data, conduct the fieldwork, and provide report on findings. In geology engineering, we learn how to draw and calculate the elevation contour of Earth's surface. The type of surface can be identified by the pattern of the contour. The geologists do some research of contour at Bumusan, Kelantan. There are a few points that have been plotted at the location. This is our tabular data. So we can see the point, we have 5 points, and then the elevation, we have 200, 300, 400, 50, and 70. So the question is, given the data in the table below, using the Newton's divided different method and natural cubic spline method to find the point 5.0 elevation. Okay, so this is the figure that we can understand about elevation of contour. So we have 230, 150, and so on.
My name is Amira Sharif. I'm going to present to you about objective and literature review. So for objective, there are two objectives for this project. The first one is to calculate the elevation by two different methods, which is using Newton divided difference method and natural cubic spline method. The second objective is to study and understand Newton divided difference method and natural cubic spline method can solve the problem of this project.
Hi, my name is NURUL IZZATI binti AMINAKBAR, matrix number CF220242, and I will continue for the presentation with the filler table. The first fact for this study, which is polynomial interpolation, and the idea is calculating divided differences recursively, and for the learning issue, understanding the concept for divided differentials and its complication application in construction interpolation polynomials. And the action is explore Newton's divided differences uses and practice applying it to solve numerical example. Next, piecewise cubic polynomial interpolation. The idea is naturally occurring boundary conditions and coefficients of the system of equations. The learning issue is understanding how to design cubic splines and finding coefficients in equation system. And the last action is eliminate situation when spines are useful and work through instead of creating natural cubic spines.
Now I'm going to present to you about literature review. So there are 3 points, which is the first one, Lagrange interpolation, second one, Newton divided difference, and the third one is natural cubic spline. So for Lagrange interpolation was written by Ran Vijay Singh at 18 October 2023. So the usage of Lagrange interpolation is to allow approximation of the function value at any desired point, including at x equals to a, using the constructed polynomials, which is a can be any point, x can be at any point. So it was given two specific points, which is x1, y1, and x2, y2 on the curve. The Lagrange interpolation formula construct a polynomial that fits these points. So for the second one, which is Newton divided difference, is a developed polynomial to fit a limited set of data points for a continuous interval. Stuart Murphy on 2022 have said that there's two process in this Newton's divided difference, which is the iterative process and degree increase, which both is needed to do this Newton divided difference. The last one is about natural cubic spline, which is natural cubic spline is a piecewise function defined by polynomials preferred in interpolation over higher degree polynomials to avoid range phenomenon. Ferguson James on April 1964 have said about this natural cubic spline is used in computer-aided design and graphics. So it often denotes as piecewise polynomial curves for ease of construction, accurate evaluation, and complex shape approximation. Its function is wide range of function used for data interpolation or smoothing one or multi-dimensional. And then the usage is a finite dimensional nature of spline function, its computation and presentation, especially in one-dimensional polynomial spline context. That's all about literature review.
Next, for the methodology. In this study, we use two methods, which is Newton divided differences and natural cubic spine. So, for the Newton divided differences and natural cubic spine are both interpolation methods, but they are serve different purpose. Newton divided difference method construct a global polynomial, while natural cubic spine provide piecewise representations with smoothness and continuity. The relationship lies in the piecewise polynomial nature of the spine, resembling the divided differences in certain aspects. Okay, next for the Newton divided difference formula. Divided from difference formulas divide difference calculating using the recursive formula like the formula given, and the cubic spine formula, the cubic polynomial on each subinterval like xi and xi plus 1 is given by the formula, where the coefficients ai, bi, ci, and di are determined by enforcing the continuity of the first and second derivatives at the interior data point.
Hello, my name is BATRISYIA BINTI HERMAN, AF2520364. Based on what I can see and my understanding of Newton divided difference is here's a breakdown of the key element and the step involved, which is one is the purpose of Newton divided difference used to approximate a function using a polynomial. That polynomial can be created to interpolate or extrapolate data point. Number two is divided different table, organize data and calculate for constructing the polynomial. The column is I, which is index of data point, xi, value of independent variable for the data point, fi naught, fi power of 0 is the value of the function fx at the data point, fi power of 1 is divided different of increased data order followed by Fi power of 2, Fi power of 3, and Fi power of 4. The first order is the slope between two consecutive points. Example, 300 minus and 200 minus with 200 divided by 2 minus 1 equal to 100. The higher order calculate the recursively using previous difference. Example, 100 minus 100 divided by 3 minus 1 equal to 0. Number 4 is interpretation. The table provide the coefficient for a polynomial that approximate the function. Polynomial can be written as px equal to fx naught plus fx naught, x1, x minus x naught plus fx naught, x1, x2 equal to x minus x naught, x minus x1, and next. Step 2 is construct the Newton interpolatory divided different polynomial which is we must identify the data, the value of x and corresponding function values fx are given. Construct the divided different table. Plug values into polynomial to find P5. Substitute x with 5.0 into the polynomial. Simplify and evaluate the performed calculation as shown to obtain the P5 equal to 600. Interpretation is the polynomial Px approximate to the function fx near the given data point. In this case, P5 equal to 600. Estimate the value of f5. The absence of a divided different table suggests a focus on applying the polynomial. The specific values in the calculation are likely based on the particular dataset. Thank you.
Next is the calculation of the natural cubic spine. So we just put all the data in the table and we calculate the FK, HK and BK, also the BK. And these are the data that we got in our study. For the step 1, we find the HO, BO, DO and BO. So in this calculation, we got HO, H1, H2 and H3 equal to 1.0. Next, for the calculation DO, D1, D2 and D3, we got this, all these are same, which is 100. For the calculation in this page, we got the BO, B1, B2 equal to 0. For next step, which is step 2, we know that M0 equal to 0 and M4 equal to 0 based on the table. So we calculate to got this equation when k equal to 0, we got one equation which is M4 M1 plus M2 equal to 0. And then we calculate when k equal to 1, we got another equation which is M1 plus 4M2 plus M3 equal to 0. And the last equation when k equal to 2, we got M2 plus 6M3 equal to 0. Next, step 3 to find M1, M2 and M3. To find this, we just write into the matrix and we got the M1, M2 and M3 equal to 0.
Okay, for the step 4, we just need to insert our data in this formula. Okay, so when k is 0, the formula will be S0 in bracket 5, we will enter all the data that given, such as M0, X, X1, and HO, F1. So the answer for S0 is 600. Okay, next is when k equal to 1. So we just need to insert our data given in the formula, which is S1 in bracket is 5. So there's the formula, and the final answer for S1 is 600. Okay, for the last one is when k equal 2. So same goes to when k equal 0 and when k equal 1. We just need to insert our data in the formula, and the last answer we get as to equal 600.
In discussion, the study used two methods to estimate the elevation at a specific point in Musang, which is Newton divided difference and natural cubic spline. This method represents different approach to interpolation, each with its own strength and weakness. The study show how both methods can be applied to solve this geology problem. While the background explains the chosen method well, mentioning other options like Lagrange interpolation could offer a broader perspective.
Okay, for the last part is conclusion. The studies show how two method, Newton and spline, can estimate elevation in geology. We use them to find the elevation at point 5.0 in Gua Musang, Kelantan. Each method has pros and cons, such as Newton is easier to use, but spline is more accurate in this case. We explain how this method work and use them to estimate the elevation. This shows how this tool can be used in real-world geologist problem. We could have also compared this method to others option like Lagrange for more complete picture.